As you know, chemical and biological manufacturing plants use hazardous chemicals and conditions, such as heat sources and cryogenic liquids. Their surroundings, therefore, are protected by multiple layers of controls, and we've spent most of the semester talking about designing the basic process control system, which plays important roles in ensuring process safety. This Google Earth image shows a polyethylene plant in Clinton, Iowa. An interesting thing about having a polyethylene plant in Clinton, Iowa, is that it's not associated with any nearby petrochemical facilities. So this plant does it all. The feedstock for this plant is primarily LP gas that is taken from a pipeline. The LP gas is cracked in furnaces that you can see here, and these shadows show the stacks on the furnaces. After performing the cracking operation, the resulting material must be refined in order to extract out the ethylene and also propylene. So there's a refinery here, which is characterized by some very tall distillation columns, the tallest of which is a C2 splitter that separates ethylene from ethane. The C2 splitter is right here. This plant also contains reactor units that produce both high-density and low-density polyethylene, cooling towers, its own wastewater treatment facility, and a railcar loading facility, where the finished product is loaded onto rail cars. Nearby, there's also a barge loading facility so that some products can be shipped out by barge instead of by rail car. To the south of the wastewater treatment facility, there's also what we call a tank farm. The tank farm consists of many very large tanks that house enough chemicals to completely re-inventory all of the vessels in the plant. In the case of an emergency shutdown event that might cause many of the processing vessels in the plant to vent to a flare, the plant would have to be re-inventoried with chemicals close to the steady state operating compositions in order to bring the plant back online. One of these tanks is an enormous ethylene storage tank. Here's a zoomed out view of the chemical plant where you can see the railcar loading facility, the tank farm, the wastewater treatment plant, the refinery, and the polyethylene production units. Additional railcars are parked off here to the right. This petrochemical plant is relatively isolated from other petrochemical plants because it's in the middle of cornfields in Iowa. But right across the highway is a mobile home park. And if we zoom out a little bit further, we can see that this is very close to the town of Comanche, Iowa, where of course there are things like elementary schools, public libraries, nursing homes, churches. There's also a nearby county park along the Mississippi River. If we zoom out further, we see some wildlife refuges, an airport, and a golf course and country club where the engineers working at the plant and their families might relax on evenings and weekends. Of course, it's important that all of these neighbors to this petrochemical plant are protected from any potential hazards that could be created by unsafe operating conditions at the plant. For that reason, all chemical and biological manufacturing plants are protected by multiple layers of process safety. These include, first and foremost, the process design. Processes should be designed to minimize potential hazards. Next comes the basic process control system, which automatically controls the process operation. The next level of process safety is alarms and alarm supervision coupled with manual intervention in response to the alarms. The fourth level of process safety is the Automated Safety Instrumented System, or SIS, and Emergency Shutdown System, or ESD. We'll talk a little bit about SIS and ESDs in this chapter. The plant also has physical protections. For example, a fence around the plant prevents unauthorized people and wildlife from wandering onto the property. There may also be physical containments like dikes that would contain a spill. The next level of process safety is the plant emergency response. These are personnel who work at the plant who are specifically trained to respond to emergency situations. For example, each shift that works at the plant has its own fire department and EMTs on duty. The plant emergency response personnel also coordinate with local community emergency response, such as local fire departments and sheriff's departments, who might have to do things like help control traffic outside of the plant in the case of an emergency. The process design aspects are things that you're learning about in CBE 451 and 452. Of course, the basic process control system is what we have spent most of the semester doing in this class. In this chapter, we'll talk a little bit about alarms. It's important to use the right kind and number of alarms. These other elements of process safety, including physical protections, plant emergency response, and community emergency response, are also important, but are largely beyond the scope of this class. In the next video, we'll introduce the idea of alarms.